This is lesson number 72 in Algebra 2, lines from experimental data and negative angles. Okay, as far as the section on lines from experimental data, all I'm going to have you do for this is just understand or get an idea of the line of best fit, FIT. Okay, and that means that when you're given experimental data on a graph like I have there in the picture, and you want to draw a line of best fit, you're trying to draw a line that is going to fit as close to possible as kind of an average for all of those points on there. Okay, so that's what a line of best fit. Just drawing a line there that kind of averages, and if you had to pick a line that was going to kind of show all those points there, that's the one that you would show. Just kind of making sure that the distance between each of the points is kind of the same, like that and that. And you know, this kind of goes between. So if I had a line that went kind of like this, you'd know that wasn't the line of best fit because it just is kind of this random pink line there. So anyway, that's really all I want you to get from that. When they're asking you to find the slope or an equation and all of that for this, just skip that part. Just draw the line of best fit and that'll be good. And we'll get into that other stuff later. The next section in this particular lesson has to do with negative angles. Alright, so let me get a graph on here. Okay, so notice my pink line. Whenever you do angles, one of the things, if you remember right, you always start here on this line and you go in a counterclockwise motion. So let's say that is a 120 degree angle. Well, if I go and come from this way, it will be a different angle. It will be a 200 and, oops, sorry about that, should be 240 degrees, because 240 and 120 is 360, and that's what it is when you go an entire circle. So that's a 240, but since we came from this direction and went this way, it's a negative 240 degree angle. So I can name that line using polar coordinates, and I can, let's say that this line is 6 long. I can name that point right there as 6 at 120 degrees if I come this way, or I can also call it 6 at negative 240 degrees if I come at it from this direction. Okay, so either way works. It's just two different ways to name the same point right there. Alright, so let's go ahead and see what they want us to do in this lesson. And we'll move the graph over a little bit. Alright, so example 72.2 says, whoops, sorry about that. Write 4, probably help if I didn't use black ink on a blackboard, 4 at negative 210. Okay, let's take our graph and find out where that is. Alright, so key thing is they told us it's negative, so I know that when I start, I'm going to start on this line and I'm going to go this way. Boy, pink doesn't show up very good, does it? Let's try red. So we go 210 degrees. So there's 90, 180, there's 210 degrees. Okay, let's get rid of that since I know where I'm at. And what we're going to do is we're going to draw a triangle. Remember, this was a little while ago. I'm going to get a darker blue on here. And we draw, alright, we know that this is 4, right? From here. And we draw a line down. And so we have a triangle right here. Alright, 4 is the hypotenuse. What we're trying to do is we're trying to change this into rectangular coordinates. So that means that we're going to have to find out the distance from here to here and from here to here so that we can use our r plus u that we do in rectangular coordinates. Alright, so we know that the hypotenuse is 4, and that's all we know. But we also know this angle right here, don't we? Because all the way around here is 210, and this from here to here is 180, so that means the difference right there is 30 degrees. So remember, what we're looking for is my x and my y, okay, when I'm translating it to rectangular. So remember, to find x, you take the hypotenuse times the cosine of the angle, in this case 30, and to find the y, you take the hypotenuse, sine of 30, sorry, that doesn't look like sine, does it? Looks like blue. Okay, so x equals 4 cosine of 30, and if we take our handy dandy calculator and we take the cosine of 30, we get 0.8660, which is 3.46. So that's my x. My y then is going to be 4 times the sine of 30, which is a half, and that's going to give me an answer of 2. So that's my y. So my x, let me get a black pen here, is going to be 3.46, and my y is going to be 2. Alright, so now I know my rectangular part of it. So it's 3.46r plus 2 up. Now, notice, did I go right? No, I went left, so that means it's negative. I went a negative direction here, not a positive, so that means my x value is going to be negative. My y, I went up, and that's what it says, so I'm good. If I would have gone down, then my this right here would be a negative sign instead of a positive sign. Okay, so that's what we're doing in that lesson. That is about it. So let me look at the first practice problem here. I just want you to kind of get an idea of what's going on. See if I can erase a bunch of this junk here. Alright, so practice problem says we have 5 at negative 230. So we're going 230 degrees this way. Alright, so if I know from here to here is 180, then I'm going another 50 degrees up there, right? So this angle right here is 50. And I've got my triangle. And I know my hypotenuse is 5. And I'm looking for my x, and I'm looking for my y. So, again, I know my x is going to be my hypotenuse times cosine of 50, and my y is going to be hypotenuse sine of 50. And don't forget to make the x and y positive or negative depending on whether you're going left or right, up or down. So you can just look at that and pretty quickly see that we're going left here and up here. Okay, and that'll determine whether the number is positive or negative. And that's it for lesson number 72.